Welcome to the CopperSpice YouTube channel, and thanks for joining us. In this video, we're going to talk about what motivated us to develop DoxyPress and some of the obstacles and issues we encountered in the process. Why DoxyPress? About a year after we started working on CopperSpice, I decided to write an overview documentation. I wanted this documentation to cover things like building CopperSpice, supported platforms, and some examples. Initially, we used Doxygen. And for the overview documentation, this worked very well because the overview documentation did not deal in any way with source code. In November of 2014, we decided it was time to actually write the CopperSpice API docs. And Doxygen started to give us some issues. We quickly ran into multiple limitations.
We looked at Doxygen and asked ourselves what the key issues were. And the largest one of these is the fact that it's unable to document modern C++ accurately. It doesn't support all C++ 11 language features, and the parser got lost frequently. We also encountered some issues with the HTML output generated by the program.
We started to look at Doxygen and even check out the internals. Is it written in modern C++? Does it use other libraries? And if so, what other libraries is it using? We also wanted to figure out how it was parsing C++. As a bit of history, Doxygen development was started around 1995. It's an open source product with a GPL license. What we noticed about the classes was that it used Qt1x classes. It's unclear if they're 1.4 or 1.5, but it's definitely in the Qt1 series. And these were the classes for strings and containers, file access, and the core functionality that was in Doxygen. What we realized were these classes were part of the Qt1 series, and they had been lifted from the Qt product and actually integrated into Doxygen. These classes are maintained by the Doxygen maintainer and not by Qt.
Doxygen is written in C++, but it does not take advantage of the C++ 11 language features. And the parsing we discovered was done using Lex only. So the Lex system is used as both the lexer and the parser for processing the input source code.
So the question is, now what? We've been in this position before. We decided to take a look at what the maintainer was doing with Doxygen, where the product was actually going, and could we submit changes and would they be accepted? It was not our desire to maintain another code base, and this was not a decision we made lightly, but we didn't feel like there were many other options available to us. We needed a way to document the API for CopperSpice, and Doxygen was a good code base to start with.
So in November of 2014, we forked Doxygen 1.8.8, and we started DoxyPress. DoxyPress is the documentation generator program. The GUI front end which existed was completely rewritten, and the new product is called DoxyPress app. And both of these projects link with the CopperSpice libraries. So where did we start with DoxyPress? The first thing we did was to replace the build system with GNU Auto Tools. We have since added CMake support as well. Since we're linking with the CopperSpice libraries, we were able to drop support for all of the old Qt1 classes. We made several other changes, as well as creating new documentation for the DoxyPress product.
In April 2015, we released a beta version of DoxyPress and DoxyPress app. In the initial changes we did, we were able to add support for the CopperSpice syntax in the C++ parser. We also created new documentation for DoxyPress. In April 2015, we released a beta version of DoxyPress and DoxyPress app. But was this enough? We started to really look at the code base for DoxyPress, and it was written in a C++ 98 style. There were raw pointers everywhere, no smart pointers, a large number of global variables, and a Lex parser only. So we started to ask ourselves, what did we need to do to make DoxyPress a really viable product?
Although this version of DoxyPress was able to generate the CopperSpice API documentation, we were concerned that as C++ and CopperSpice continued to evolve, it would no longer work as we needed.
The container classes in Qt 1x were all pointer-based. Although we were using the CopperSpice container classes now, all of the code in Doxygen relied on the fact that the containers were pointers and not values.
The Qt 1 container classes used an auto-delete memory management scheme. And what this means is that while a particular object may be present in multiple containers, one of those containers is responsible for the deletion of that object when the program is finished. It was extremely difficult to untangle this memory management scheme and prevent memory leaks. Another issue we ran into was a lack of the appropriate containers, and so certain containers were used in ways that they weren't intended. This is some representative code from Doxygen that simulates a set using a map where the value is a void star that is always set to 666. Since CopperSpice has a real set container, we were able to clean all of these up once we understood what this code meant.
The code on this slide is actual code from Doxygen, and it shows the interdependency and the problem when a class inherits from a container.
So let's look at this starting from the bottom, because we wanted to know what a file name dict is. And it's a qdict, which is like a map. It's a map where the value is a file name. A file name consists of some information and a file list, where a file list consists of some information and a list. It was extremely confusing to work through this class hierarchy and try to determine where things were duplicated and what any of these classes actually means.
In the current version of DoxyPress, we've been able to clean up some of this code, and we still need to continue to refactor more of it. Classes like FileList should simply not inherit from a container. Here's another problem we ran into. The string class, which was from the Qt 1x library, returns a null character if you go off the end of the string. We switched to using QString, which is part of CopperSpice. This doesn't work in QString, and it produced a runtime error. The problem is, how do you check for this and how do you find this?
To resolve this issue, we searched the code for @ and we looked at every place where this method was used. And that wasn't so bad. But unfortunately, there was also an array index operator, which meant we had to search the code for open square bracket. And this we did. In order to fix these problems, we had to ensure that invalid elements in a string were never accessed. So at first, we made the straightforward translation of just checking the size before accessing the string. But after a while, we realized that it was actually much more readable when we used methods like starts with, which represent the actual intent of the code.
Another problem we ran into with Doxygen was the use of macros to simulate a variadic template. There were places in the code we were able to remove several hundred lines and replace it with just a few lines of a variadic template. There were also parameters which shadow member variables, which made reading the code extremely difficult.
But the real readability challenge was the naming of variables. There were simply too many short variable names that were too similar. There was one point in a nested loop where the loop variables that were in scope were I, li, and lli. And this was extremely difficult to read.
In the refactoring process, we have worked very hard to change the variable names to something that makes sense in terms of what code we are working on.
Here's a list of some of the other items that we worked on in the code base. And I'll call out particularly the extra div tags in HTML output, because this makes it nearly impossible to generate the look and feel that you would like for your documentation by adding a CSS style sheet.
We've mentioned several of the things we've changed in DoxyPress, but the ultimate and real problem is the parsing. Parsing should be done in a two-phase approach, where phase 1 is the lexical analysis, and phase 2 should be the semantic parsing. This would require using Lex and Bison. But Doxygen uses only Lex for both phases. This approach may work for a simple language, and it actually does, but for something like C++, this just simply does not work.
In Doxygen, not only is the parsing implemented entirely using Lex, but a single Lex parser is used for many different languages, including C, C++, C#, Objective-C, D, IDL, Java, JavaScript, and PHP. It is an extraordinarily complex lexer with over 800 different rules, and many of these rules are active in multiple different languages. It's not always clear which languages a given rule affects, and it's very challenging to maintain this parser without breaking at least one of the languages it supports. Lex is very poor at handling look-ahead in a grammar, and it also has major performance implications, but look-ahead is used extensively in this parser. And new rules have to be added to this parser every time any of these languages has a change in syntax. With the advent of newer versions of C++, this becomes extremely difficult to maintain.
So we realized early on that DoxyPress really needed to use something different for parsing C++. We use libclang as the way to generate the cursors to pick up all the comments in source code. And we're using libtooling for the AST nodes to generate the constructs for C++. The advantage we gain by using libclang and libtooling is we get to leverage all the changes that are made in Clang and keep up with the C++ standard. We no longer need to maintain the Lex parser.
So where is DoxyPress today? We've made many improvements. We've enhanced the source code to use modern C++, and we've migrated much of the code base to use shared pointers instead of raw pointers. As we mentioned, we use Clang for C++, which gives us an accurate and correct C++ parser. For example, if you have a method in your code which is virtual, we know about it even if you don't use the keyword virtual in front of that particular method. So your code is documented with its actual meaning rather than what your code says in the source. We have also made major improvements in the speed of documentation generation and the manner in which Markdown is parsed. DoxyPress is a maintainable and readable and extensible project, and we view it as the first postmodern documentation generator for C++.
There are many other changes we have in mind for DoxyPress, and we're looking forward to altering some of the internal class structure and making the product even more powerful and more dynamic for end users.
For more information about DoxyPress or any of our products, please visit us at www.CopperSpice.com. You can access source binaries and documentation for all of our products on our download site, or find our main source code repositories on GitHub.
Thank you for watching our video, and we hope you found the content of value. If you have any questions, feel free to email us or leave us a message on our CopperSpice form. We really want to hear from you.
Please make sure you subscribe to our YouTube channel and come back in 2 weeks for our next video.